Hello friends, I am Chandan. In last lecture, we complete the polytropic process heat and work transfer formula. This is my handwritten notes useful for GATE, ESC, SSC JE, ISRO, DRDO, BARC and other competitive exam. The PDF link is given on the description. You can download it. Now, this video is useful for only for mechanical engineer. You can see that video. Now in last lecture we just completed the polytropic process work, that is the formula, that is we got the formula, uh, this formula del q, del q polytropic, that is equal to gamma minus n upon n minus 1 into gamma minus 1 p1 v1 minus p2 v2. We got this formula. From here we got this formula here, del q polytropic, that is equal to gamma minus n upon gamma minus 1 into del q del w poly. Okay, so this is the relation we got in for any polytropic process. Now here remember this formula here. Now just remember this formula. So del q poly, that is equal to gamma minus n upon gamma minus 1 into del q del w poly. Okay, now let's try to understand. Suppose one interviewer say that there is a system here, there is a system and you supply the some amount of heat, suppose 60 kilojoule of heat to the system. What is the work? Okay, and consider it is a polytropic process and all the n and gamma value are given. N value and gamma value also given. N value is 1.2 and gamma value is 1.4. We know that 1 less than n less than gamma, we know that. So basically just the interviewer say that try to find out the polytropic process work. Okay, so we know the polytropic process work, that is equal to del q polytropic, that is equal to gamma minus n upon gamma minus 1 into del w poly. So del q poly 60 kilojoule heat is into the system, so 60 kilojoule, that is equal to gamma, the value of gamma, that is equal to 1.4 upon minus 1.2 by 1.4 minus 1 into del w polytropic process. From here you can get the value del w for polytropic process, that is equal to 120 kilojoule. So from here you can get this value, that is w equal to 120 kilojoule. And the interviewer said that, suppose interviewer say that what is the efficiency. When you see the efficiency, then you find that efficiency, we know the formula, that is output by input. So here output is 1 w is the output and heat is the input. So we get 120 by 60. 120 is the work and work transfer and 60 is the heat transfer. So we from here we get that is 200% efficiency. So the interviewer say that this is 200%, but here just the interviewer say that you apply heat 60 kilojoule and you got 120 kilojoule of work. How it is basically possible? So in that way interviewer asked question to you. So the answer is that basically the here heat is 60 kilojoule and work is 120 kilojoule. Basically in the system the internal energy of this system is decreases during the process, that is why the work is increases. So that will be your answer. So the answer is also given here. Conclusion is that conclusion is that, conclusion means the answer of this question. So polytropic specific heat is negative, imply that we supply the heat to the system or gas. Okay, so here in last lecture we just completed, that is c poly, that is equal to gamma minus n into r upon n minus 1 into gamma minus 1. So from here n minus 1 is positive value, this is positive value, this is here this is positive value and gamma minus 1 is also positive value, r is positive value, but here gamma minus 1 gamma minus n is the negative value, so that is why C poly is the negative value. So here the conclusion is that polyatomic specific heat is negative, imply that we supply heat to the system or gas, the temperature of the gas will decrease for 1 less than n less than gamma. Acha, so what is the answer of this question? Basically the answer is that in this case the amount of work done is more than the amount of heat supply. Okay, and this additional work will come from decrease in internal energy. So the additional work is coming due to the decrease in internal energy. So that will be your answer. Basically that will be your answer. Okay, so this is my handwritten notes, you can download it from the description. Okay, no need to write anything when you see lecture. Okay, now let's try to understand a question. So here a fluid is confined in a cylinder by a spring loaded frictionless piston, so that the pressure in the fluid is a linear function of volume. Okay, internal energy of the fluid is given by the equation U, that is equal to 34 plus 3.15 PV, where U is in kilojoule, P in kilopascal and V in meter cube. If the fluid changes from initial state of P1, the value is given 170 kilopascal and V1, that is 0.03 meter cube, to the final state of P2, that is equal to 400 kilopascal, V2, that is equal to 0.06 meter cube. Find the magnitude and direction of heat and work transfer. You have to find the magnitude and direction of heat and work. Okay, basically this question is a large question, but don't this is very easy, just understand it. Okay, so here what is given, this is a linear function. So here linear function of volume, so pressure is the pressure in the fluid is a linear function of volume, this is given, and there is an internal energy formula, that is 34 plus 3.15 PV, and the initial pressure is given and initial volume is given, and the final pressure and final volume is also given. You have to find out the magnitude and direction of heat and work. Okay, so here just write this formula. So here there is a formula, this is the relation here, this is the relation U equal to the relation is given in the question. Okay, so U, that is equal to 34 plus 3.15 PV. So the initial pressure and initial volume is given. So from here you got, that is this 34 plus 3.15 initial pressure, that is 170 kilopascal. So 170 into 10 to the power 3 into volume, that is 0.03, that is given in the question. So from here you can get 160.99 joule, and from here you can get 16.099 kilojoule. Okay, 1 kilojoule equal to 10 to the power 3 joule. 1 kilojoule, that is equal to 10 to the power 3 joule. Now from P to V2, the P to V2 value is also given. From here, that is 34, the constant is given, and 3.15, and pressure is 400 into 10 to the 3, 400 kilopascal is given. So it will be 400 into 10 to the 3, and volume, that is equal to 0.06. From here you can get, that is 75634 joule, and from here you can get 75.634 kilojoule. Now if you want to calculate the internal energy difference, that is U2 minus U1, so from here you can get U2, that is equal to 75.634, so that is 75.634 minus 16.099 from here. Okay, so from here you can get this data, that is U2 minus U1, that is equal to 59.535 kilojoule. Okay, so this is the internal energy difference. You can get this internal energy difference. Now in question there is a spring. Here in question there is a spring loaded is there in this question. So there is a spring loaded. So that is why the spring loaded means there is a linear straight line. So if you draw this process on PV diagram, so you got here P1. So this is the initial state here, this is the initial state, and this is the final state, and this is the straight line because there is a spring is given, and here this is the initial state and this is the final state. Okay, 2 is the final state, and initial pressure and volume is given, that is this, and final pressure and volume is given from this question. Now if you want to calculate the work, the work will be the area under this curve. So under this this is the area. Here this area will be work done. That means if you want to calculate the work done, then only this area, if you find out this area, this will be your work done. Okay, will be your work done formula. So from here you get from trapezium, you know the formula. So W, that is equal to half into 170 into 400. Here there is 170. Here the pressure is 170. So basically this axis difference and this axis difference. So here 170 plus 400 into 0.06 minus 0.03. From here you can find out this formula. So basically this is this area. You just find this area. If you find this area, this is the here. You got this 8.55 kilojoule. 8.55 kilojoule plus 8.55 kilojoule. And if you want to calculate the heat transfer, that is, you know the first law formula, that is del Q, that is to du plus del W. So del Q, if you find out the Q, that is equal to U2 minus E1 plus W. So U2 minus E1 is already determined. So 59.535 plus W, that is equal to 8.55 kilojoule. So from here you can get this value, that is 68.085 kilojoule. So this will be your answer. So this is the answer. So here what is given? The magnitude of heat and work. So the magnitude of heat and work. So basically here the magnitude of heat and work. So the magnitude of heat, that is equal to this, and the magnitude of work, that is equal to this. So here the work is this and the heat is this. So this is in your answer. Okay, now there is another question here. A gas of mass 1.5 kg undergoes a reversible expansion process, follows the law P equal to A plus BV, where P in kilopascal and V in meter cube, and A and B are constant. Initial and final pressure are 100 kilopascal and 200 kilopascal respectively, and corresponding volume are 0.2 meter cube and 1.2 meter cube respectively. The specific internal energy is given by U equal to 1.5 PV minus 8.5 5 kilojoule per kg. So basically this question is similar to the above question, just completed question. Okay, so here calculate the heat transfer and maximum internal energy of the gas. So just read the question and find what is given in the question. Just write what is given on the question, and after that if you solve this question according to this, then you find the formula. So there is answer is also given. Just try to uh, just finish by yourself. Okay, the answer is also given, you can find it, but first you have to solve this question. After that, if there is any problem, you can find this answer. So this is my handwritten notes, you can find out from this description link. Okay, now there is another question. A fluid system contains in a piston cylinder machine passed through a complete cycle of 4 processes. The summation of heat transfer for all process is minus 340 kilojoule per cycle. So this is the data is given, that is minus 340 kilojoule per cycle. The system complete 200 cycle per minute. Complete the following table and find the heat transfer and neat work transfer in kilowatt. So there, the table is also given here. This table, there is a process, there is a 4 process, 1 to 2, 2 to 3, 3 to 4 and 4 to 1. In that process, the heat is transfer, the unit is kilojoule per minute, and work, that is kilojoule per minute, and du, that is equal to internal energy change, that is kilojoule per minute. So here this data is given, this data is given. You find out this, you have to find out this data here in process 2 to 3. This data is given and this data is also given. You have to find out this data, and here this is also given and this is also given. You have to find this data, and here you have to find all the data in process 4 to 1. And just try to solve this question. This is very easy question. Just apply the first law of thermodynamics only, then you can get the answer of this question. Okay, the answer is also given in the PDF, you can find it from this. Okay, just try to solve this question first. Okay, now next question is that an insulated rigid pressure vessel is divided into two partitions by a movable partition. One part of the vessel is occupied by an ideal gas at a pressure of P1, volume V1, and temperature T1. The other part is occupied by the same ideal gas but at pressure P2 and volume V2 and temperature T2. The partition is removed and two partition mixed adiabatically. So here two partition mixed adiabatically, so that the final pressure P3 and final temperature T3 are given by here you have to just prove that just P3 that equals to P1 V1 plus P2 V2 upon V1 plus V2, and T3 that is equal to P1 V1 plus P2 V2 upon P1 V1 by T1 and plus P2 V2 by T2. Just you have to prove that. Okay, so try to find this the answer. Okay, the answer is also given, you can find out this all the data figure is also given, and here the answer is also given, here the answer is also given. Now the last topic of this lecture, that is Mayer's equation. Mayer's equation basically is that Cp minus Cv, specific heat at constant pressure minus specific heat at constant volume, that is equal to R. R means characteristic gas constant. So how to find this formula? How do they find out this formula? So you know the enthalpy formula. The enthalpy formula, that is equal to H equal to U plus PV. There is no assumption. So if if dH, from here you can get dH that is equal to du plus mr dt. Why it is mr dt? Because there is one assumption is added. This assumption is an ideal gas assumption. Okay, so you know the formula, ideal gas formula, that is equal to pv equal to mrt. So from here dH, you can say that dH that is equal to du plus mr dt. Okay, pv is one, pv equal to mrt. So pv equal to mrt from here. So this is dH, that is small enthalpy, and du, so this is the here this is small dH, du, and mr dt, small element. So from here dH you can find, dH we know that mcp dt, and du if know that mcp dt, and this is mr dt. So cancel out from every, m cancel out, and dt and dt cancel out. From here you can get cp minus cv, that is equal to r. So this is only valid for ideal gas. Okay, this is only valid for ideal gas. Okay, so like, share, subscribe my YouTube channel. Thank you. The link is also given in the description, and there is a Telegram link. Join this Telegram link, because all the video which is published on the YouTube is also share the link, also share in Telegram group also. So just join this group, and like, share, and subscribe my YouTube channel. All the mechanical engineering PDF are given in this, um, in this in my YouTube description. All PDF are given, so don't go anywhere. Okay, if you find out that you self study, only required self study, so just follow my notes. Don't go to anywhere. And if you have any doubt, then you can connect me through comment, or there is a mail id is also given. And I want to say that just focus on one topic, because in everywhere, if you see one video, another video, and another video, then your mind is diverted, your time is wasted. So that is why I say that you can follow me. Okay, so you can follow me. Okay, thank you.